First image you see is the power switch on my lathe, and I have disabled it. And I want to make sure that if anybody attempts something like the spiraling jig, or any other attachment for that matter, disable the power to your lathe. You can get into a rhythm of powering, in this case, it's a little laminate trimmer that's doing the work. And you get into a back and forth, turning it on and off, and then eventually you're able to make the mistake of turning your lathe on when it's kind of harnessed to this thing, and you're going to destroy everything and possibly endanger yourself. So I pulled the little yellow key out of my switch before proceeding. This is just a short video showing, and by the way, what you're seeing displayed on the rig there is a more complicated, that's a 2-gear system that I made, and I've since redone it as a 1-gear system with the full capability. And there you see a pretty steep spiral angle that was just done to show the steep angle. The components of the system are, let's see here. The white material you see there is 1/2-inch expanded foam, PVC, that you buy as like waterproof building material at Home Depot. It comes in 2x4 foot sheet, and it comes in 1/4 and 1/2-inch thick. This is 1/2-inch thick, and it has had a groove or a channel put around its circumference to accommodate the belt that you can see coming off it on the left-hand side. This is a 6mm wide timing belt with a 2mm tooth spacing, and so you can get pretty fine control. It has the belt has 90 pounds of tensile strength, so it's pretty rugged. And it simply goes on by a little half turn of a piece under the bed of the lathe that locks it in place. And you can see there's an indexing pin. I have drilled, in this case, every 30 degrees in the rim, and a little indexing pin so you can accurately space your grooves. I could have put in more holes, but I just stopped at 12. And you see here, as you crank it, there's a 1/2-inch, 13 thread per inch shaft. So you unlock the head, move it to an index position, retension it. And most importantly, don't forget to pull the pin out, as I've done a couple times. It'll ruin your work if you leave it in. And the carriage you see in the foreground, it doesn't have the turret on it yet, but okay, there's the carriage. It's made to a pretty tight fit, and the most important thing is you see on the left-hand side where the threaded rod is in I took a 1/2-inch connector nut, I think they're called, at Home Depot sells, and split it long ways with a, what do you call it, a cutoff wheel, and cemented the two halves there so it permits rapid movement of the and positioning of the cutter head by lifting the shaft up out of the thread, sliding it to where you want it to be, and dropping it back in again. And it can run with just the lower half, but I've been, because my rod, and an important thing to consider if you do undertake something like this is that when you pick out threaded rod, roll it on the floor. If you buy it at Home Depot or wherever you buy it, roll it on the concrete floor or something to check out its trueness. It looks straight to the naked eye, and I bought it, and it turns out that it's got about 1/8 of an inch of bow, and so it adds an irregular one time per rotation load on the crank system because of, straightening out the shaft each turn. So buy straight shaft. This is just showing the head can pivot and plunge. And this is on the tailstock end. It's just it's one of these magnetic switches that you can lock it down so that when you get cranking rapidly, the bent shaft starts to whip. And so that thing kind of holds it in place. And this little piece right here is an important thing if you're doing contour work that you'll see later on in this video. It's a nose piece that just made from PVC and some cherry and an aluminum nose cone. And it permits up to a 3/8 diameter cutter to penetrate it. These are the size sprockets, either a manufactured sprocket. You get them on Amazon for about $3 a piece. And they are Chinese made in aluminum. The groove there is about 5/16 wide. And it has the tooth pattern for the timing belt, which you're about to see coming up. This is the timing belt material. It's 6 millimeters wide, so it's right at 1/4 of an inch wide. And you can buy it in like a 10-meter length or a 5-meter length. And you can also buy it in pre-made loops, like belts, in all kinds of sizes, pretty much every size you could imagine, up to about a little over 1 meter long and all the way down to about 1.5 inches in diameter. And it's got some cases fiberglass and some case Kevlar strands reinforcing the spine, which give it its strength. Otherwise, it's neoprene. Here's an example of a constant diameter spiral. In this case, I'm making a candlestick just for the demo. It's just a piece of cherry that I bored out to a 1-inch bore on the inside, 1.5 OD. And it has a plug put in one end, and it plugs into a standoff on the headstock end. And this is a CNC cutter, a 1/4 inch up spiral CNC cutter in this little Harbor Freight $32 laminate trimmer I have harnessed down here. In this case, I'm going to do 6 binds, as John Kelsey told me they're called, 6 strands basically in the spiral. And so I'm going to do with every even number on the index wheel. And because it's all the way through the side, I'm not putting the nose cone on. You just go into I have a depth stop block on the bottom. So I'm only going halfway through. I'm going about 1/8 or 3/16 of an inch deep here. And I'm just holding it in manually while I crank it. And this is kind of a moderate spiral. I could do it a lot shallower or a lot tighter. Excuse me. And you really have to crank this thing by hand and not lift the threaded rod out of the thread, or else you're going to have a hard time getting alignment for each of your index slots. You have to adhere to the pattern. And if anybody has questions, I can pause this whenever. Then we advance at 60 degrees, pin it.
Barry, can you explain, though, you just said that you can make a more steep...
I'm sorry?
You mentioned a minute ago that you can make a more steep or aggressive groove, but wouldn't my understanding be that the thread pitch of your rod will give you the same groove. You know, it looked like it was one rotation. Just
I
about.
did one rotation. It's about to do a second one, and then I fast forward to the last rotations. When I talk about tighter or steep, I'm talking about basically the angle that the helix makes with respect to the longitudinal axis.
Right.
That by changing the gear head, by changing the sprocket on the wooden head over there, I can make it from anything on down to where it's only advancing about 1/4 of an inch on a rotation, all the way up to where it's doing like a 1/3 of a turn on a 15-inch length. You know,
Okay.
just barely,
Okay. So that's
barely spiral.
that sprocket is hidden right now in this picture. That's right to the left of your left hand.
I'm sorry?
That sprocket is to the left of your left hand in this picture.
What you're seeing just above my hand in the wood there is the final sprocket, and that's always going to be a 20-tooth. All of the output sprockets are 20-tooth sprockets. The input sprocket, which is on the back side of the plywood, you can't see it there. I'll show it in a little bit.
Okay.
But that's
Okay.
what you change. You change it. You can put it on a 20, a 40, a 60. And on the new system I made where they are handmade, I made my own sprockets. Because 60 is the biggest you can buy unless you're going to go up to a bigger belt. I mean, like a wider, thicker belt.
Right.
But for this size belt, the biggest manufactured sprocket that I've been able to find was 60 tooth. It's about 1.5 inches diameter. And so I made some that were up to 200 teeth. And by the way, the big white wheel you see has 400 teeth in it. And so it has anywhere from a 400 to 1, I'm sorry, a 20 to 1 reduction to about an 800 to 1 reduction. And that controls how steep your helix is on the spiral.
Gotcha. Okay, that was very helpful. Thank you.
Okay, so I think an improvement will be if I could get some kind of a spring-loaded pin mechanism so that it always unlocks itself, because you can really screw something up if you're cranking and the router is advancing, but the wheel's not turning. You just get a longitudinal groove. There I have, at this point now, I have 5 spirals in it. I'm putting in the final one. And again, this is only like 3/16 of an inch deep. It is not going all the way through to the hole, to the bore on the inside. That's coming up. And that also kind of demonstrates its repeatability.
Barry, do you have a stop block at the end, or do you just eyeball that?
In this case, I'm using, if you look just below the collet on the router, you can see a little C-clamp.
Yep.
Holding a piece of wood there. And that's my left limit. And out of sight on the right side is the right limit. And right at the bottom of the screen, you can see a bigger C-clamp holding down a block of wood. And that limits my plunge depth.
Gotcha. Yep. Okay.
I just, cut off scrap pieces of wood for different plunge depths. And so there I have it. So I'll go in halfway through, and I slide the block all the way to its hilt, and that allows me to go through. So I'm moving about a 1/4 inch deeper.
Right on cue.
Okay, so here I'm piercing the sidewall. And in this case, I'm keeping the cutter in on the return because it cleans the groove up a little bit You know, because there's a climbing and a descending grain here, and it helps clean it up if you cut it both ways.
Barry, do you have that on your big white wheel? Do you have any with other options other than 12 positions?
I'm sorry, do I what?
Have any with like 9 positions instead of 12 around the circumference?
Well, I have a you know, a regular commercially made indexing plate that pretty much has every angle there is, and I could have drilled more holes. I just I couldn't get, if you make too many grooves in here, your object falls apart because it, and I had that happen with one piece. It becomes too unstable with the tailstock pressure, and it's like a coil spring. It collapses on itself. And so you don't want to put in too many spirals.
No, I was just wondering, like, for example, I have 3, I can see 12, I can put in 3, 6, but if I want to say 5 spirals instead of 5 spirals, I can't use that particular indexing block, that's all.
Yeah, I could go ahead and the scroll chuck here is what's capturing the wheel, you know, just by friction. I could also go ahead and in front of that add the indexing plate, although then I'm down to only about a 3/8 of an inch of chuck holding. But anyway, I could put an indexing plate and do every 3 degrees, 5 degrees, 7 degrees, you know, whatever number you want. And I would make such an overlay if I were going to do that. But this was just for this is all basically prototype right here. But yes,
understood.
I could put holes wherever I wanted to.
Okay, thank you.
Wow. That's really cool.
And then there's the handwork. And I have experimented with putting a roundover bit in there as well. And it chatters a lot, but it does it. So here's that goblet that I had on to how could I improve the goblet in the coffee hour 2 weeks ago. This is the goblet still on its foot. And this is the demonstration of using the nose cone to follow the contour. And I'm using, in this case, masking tape to delineate left and right travel. And you just have to watch it so the wood dust doesn't cover up your masking tape and you forget and you go beyond it. This goblet has pretty much a consistent 1/8 inch thick wall. And so you set the router to about the mid angle. And then the aluminum nose cone is rubbing on the wood as you advance it, so you just keep steady pressure. And here you can realize that how the spiral changes based on radius of your workpiece. And you see, John Kelsey filmed this part right here, by the way. And you can see how it gets, the helix gets a lot steeper or a lot shallower as you get bigger in radius. In this case, I'm using 12 cuts. So it's every 30 degrees. And the black line that you can see next to each groove is just the residue from the aluminum nose cone. There was no, I didn't do any artwork on it.
I'd like one of those for my kids when they steal my scotch. It's a neat
So here's
design.
the final pass on this goblet. And you can see it set at maybe 10 degrees of angle, which is approximately the halfway down the slope.
And you were just putting that perpendicular to your starting point, correct?
I don't know what you mean by perpendicular to my starting point.
You're cutting material. You're cutting bit to start that when you've got that kind of compound curve of your goblet. Are you starting that at a perpendicular? Was that your 10 degrees you were just talking about, Barry?
I'm starting it at, if I just eyeball the goblet up near the right toward the tailstock end of the cut, the slope on the wall there is only about 3 or 4 degrees. As you get down toward the base of the goblet, the slope is up to maybe 20 degrees.
Right.
And so I kind of averaged it out. I put just a kind of dry run, I put the cutter down about halfway and put it perpendicular to the local surface at that point.
Okay. So you found a median. Yep. Gotcha. Okay.
Yeah, you cannot pivot while it's in motion. I would analogize it to trying to draw a circle with an Etch-a-Sketch. I tried it, and the cutter is, it's very jaggy and all over the place, and so you really have to do it without changing the angle, or having to. You can swing this plunge into where you are cutting on a given radius, and if you were like cutting spirals in a globe, in a sphere, you could then go ahead and traverse it all the way along the longitude, always being perpendicular to the surface because you're rotating it as you move it along. Well, actually, you're not going to crank it at all then. You're just going to rotate the pivot head.
Right.
Okay, so here it's coming off the chuck.
Wow,
I'm showing it off. And this is, by the way, called the Holy Grail.
That is really nice.
Yeah, very unique.
And
I love that. Thank you.
for reverse spiral, obviously you cannot do all the way through the wall. If you go through the wall and then reverse the angle, you're going to be cutting everything out and it's going to all fall away. So just for like a trace pattern or a groove pattern that I'll show here, we're doing a reverse mechanism, and it's kind of coming into picture here. I can't back it up a little bit, unfortunately. But in this double image, you can see there are, in fact, 2 gears here. I took a sprocket. I took a pair of 42 sprockets and machined the flange off them. And you see them there.
Yep.
And well, actually, only the right one has the flange turned off. The left one is as it comes from the manufacturer. And these all come, by the way, with a 5 millimeter bore, which is right about 3/16. I've enlarged the bore on all these to 1/4 inch, just so it was a more stable shaft that it's on. If anybody has a set of spur gears, a pair that are the same number of teeth, it's definitely a superior solution to these. A, these are aluminum, and B, they are not involute gears. They're just little half-round teeth. And so their action is not the smoothest in the world, but they're like $3 a piece versus I did price out even nylon gears are approaching $40 per gear.
Oof.
I was trying to keep the price of this whole thing under about $100.25. I have spent more than that because it's prototype and I went through several iterations, but a production could be made for about $100.25. And this was the piece that I did forward and reverse spiral. Okay, and here on the bottom 3, you're seeing smallest to largest, 20, 40, and 62 gears that you can buy. And the upper ones are the ones I made from this 1/2 inch foam. And they are, as you can see, labeled 80, 120, and 160. I also made a 200, but I did not yet at this point put a hub in it. The hubs are all cut from, in some cases, 5/8, in some cases, 3/4 inch aluminum rod.
Barry, is the gearing on those just the same belt, just glued in around the circumference of those?
The hub and the disc.
The disc itself, I see the teeth on the disc on the circumference. Is that just the belt that you're using that you just glued into the circumference?
Okay, what I do is if I decide it's going to be, let's just say, a 100 tooth sprocket, it's pretty straightforward math. You got 2 millimeters per tooth, so you got 200 millimeters divided by 25.4, and I got inches.
Right.
And so I cut a piece of belt from this 10-meter long roll that I have. I cut a piece of belt that long, like say 15.5 inches. And I know the conversion at this point on how big of a diameter to make to accommodate that. And so after roughing out the outside diameter, I go ahead and cut a channel so that it has about 1/8 of an inch flange, and trial fit the belt to the land, the channel land, and cut it down sequentially, just keeping that advancing like, a few thousandths at a time. Takes 5 or 6 passes,
Right.
until I get it to where the ends of the belt work out to exactly matching with the 2 millimeter spacing between the last pair of ridges. If I go a bit too small, I just put 1 or more turns of double thick tape on there to build up its diameter to where it is the right size. And the tape doesn't have to go all the way around. You can put like 1/3 of a turn or whatever is required to get the proper spacing. And after it's all fit, you just put a drop of a CA at the joint, and it locks the whole thing in place.
Oh, wow. Okay. Interesting.
So here I'm just showing changing from one sprocket to another. No, I'm showing you how to change it from forward to reverse. That's what I'm doing. I forgot here. So on the opposite side are the pair of machined sprockets. And I'll pause it right here. And if you see like 1 inch away from my index finger, you'll see the sprocket that comes up from down at the very bottom is the sprocket coming through from the drive shaft. And that comes up onto a 20-tooth wheel, so there's no gear reduction or anything there. And in the third leg of that triangle of that belt is an idler pulley. And then up at the top end, if I put the final belt on the left sprocket, I'm going in what I'll call the forward direction. If I put it on the sprocket that I'm putting it on right now, I'm going in the reverse direction. These are little swing arm idler pulleys that I made from, they could be made from plywood, but these are made from aluminum. Here's the forward side, and the drive shaft goes through it there. The hole over on the far left bottom corner is a 1/4 inch hole, and it has a T-nut mounted on the back side, and that's where my crank mechanism, my little hand wheel, mounts to that T-nut. The 1/4 inch hole that you see a little bit further up and in the middle there is for an idler pulley. And all the idler pulleys are a simple pivot, except for that you see that one slot. It's a 1/4 inch by about 1.5 inches long slot. And that's because the final pulley can be any of, right now, 4 diameters. There are endless number of diameters. And so the idler pulley has to be able to accommodate any of those diameters. So it has to have more than just a swing arm. It has to also be able to slide. But you just put it in position, lock it down, and there you are. That's probably it.
Barry, one more time. I'm sorry. That the thickness of the drive rod, is that a 1/2 inch or what was
The drive rod is a half half-inch diameter. It's a 1/2 13.
13. Yep. Okay.
Yeah, it's a standard coarse pitch. And I will say this: the coarser the pitch, the less gear reduction you have to do. The drawings will really be the profile drawing dimensioned out for the spacings so that it fits ready-made belt. I don't have it right now, but I'm going to make the drawings up and put them on the Lancaster Area Woodturners website as PDF files. And a user just has to keep in mind to adjust where everything starts based on how high their cutter head is, how high their spindle is from the bed. In my case, this was a jet 14-inch lathe, and so it's the spindle head is 7.28 inches above the bed, and my drive shaft I have hanging off the edge of the bed by about 1/2 inch so it can clear the tailstock. So you can slide the tailstock while this thing is in place without any interference. And so you just have to know you just want to keep the gear cluster with the dimensions that I will show as far as with respect one to the other. And then standard available belts. And these belts are about, on Amazon, they're sometimes like 2 for $8 or 1 for $8, depending on who the seller is. A number of American companies like Stock Drive Parts at sdp.com, I think, they have a full array of belts, and you're pretty much paying by the length. And a typical belt is about $5, but you have to get a minimum purchase, or they're going to hit you with the $10 surcharge. So if you're buying fewer than about 6 belts, you're better off going through Amazon, where everything you get in 2 days and it's free shipping. And I know Mike Junkers is a big fan of AliExpress. AliExpress has all this stuff significantly cheaper, but you're buying like 5 sprockets at a time. And it's hard to get their website is not as well constructed as Amazon's, and you have a hard time understanding if you're buying, what size you're buying.
Yeah, I agree with that for that kind of precision.
Yeah, so I would say stick with Amazon or go on to a place that sells to consumers. Stock Drive Parts is a good example. And they also sell gears and everything. They sell the belts, the sprockets, and gears.
Barry, just a quick question. You mentioned about machining some gears and doing things. Did you do that on your wood lathe, or do you have a metal lathe there that you used for doing material machining?
I have a Grizzly machinist lathe. I would say every place where I used aluminum, except for the commercial hubs, but every place where I used either the PVC foam or made the wheel myself, nylon works as well as aluminum. And you can machine the nylon, but you can machine aluminum on your lathe too, as long as you have the right size chuck or collet or whatever you're going to grab it with.
Yeah.
I would say if you have jaws that are made for pen turning, you could probably hold the hub. But I glued the hub in and then turned the diameter and the channel. And I do it with the wood lathe tool. I just rest it on the machine tool rest. But nylon works as well, not Delrin. Delrin machines beautifully, but nothing, as far as I know, will bond to it. Matt, if you're still out there, you're familiar with Delrin. Maybe you know some secret that will bond to Delrin. But I made a series of wheels and I used Delrin hubs, and I was really impressed with it. What's that?
So what I hear you saying is that somebody with a drill press and a wood turning lathe could put one of these together, is what you're saying.
Right, except for making the reversing gears. And if somebody wanted to bring me the sprockets, I'd be happy to. And it's a 10-minute operation to cut the flanges off the sprockets for the reversing gears. Otherwise, it's all woodwork and foam work.
Okay.
Hey, can I make a suggestion locally on that you might look at is, I don't know if you're aware of Brown Transmission on Greenfield Road, but whenever I've needed bearings or belts or anything like that, I'm just taking what I have in there and they match it up. And if they don't have it, they can typically get it for you within a day or so. But they're right there on Greenfield Road, just down from Costco.
Okay.
What company is that, Johnny?
It's called Brown Transmission. They specialize in all kinds of gears and belts and bearings and all that stuff, for industrial type applications and stuff like that. I've had to get a couple of different items for my bandsaw and a couple of different tools I've got. I've went online to look for stuff and they said it was back order or not available. I'm just taking the old bearing in there or whatever I have and put it on the counter and they matched up, and there's only been one time I've gone there that they didn't have what I needed, but then they got it to me within the next day.
So they do have a walk-up counter for that?
Yeah.
Good to know that.
Okay, more questions for Barry?
Hey, thanks for showing us that, Barry. That was very cool. Thanks for the effort.
Okay, thank you.
Yeah, that was really amazing, Barry. And just to let you know, as far as I know, there isn't a glue that bonds Delrin.
Yeah, it was kind of annoying that I went to.
Now you tell me.
It machined so beautifully, and you can use almost any kind of cutter to machine it. And then I put the crazy glue, instant glue on it, and it just laughed at it. It just fell right off.
Yeah.
But nylon, like you can buy bushings at Home Depot, 1/4-inch bore with the 5/8 or 3/4 outside diameter in their little parts bins there. And that white nylon, the black nylon behaves the same way as Delrin. The white nylon aggressively bonds to CA.
Good to know.
That's good to know.
Yeah.
Great job, Barry. Thank you.
Yeah, great job indeed. So
Well, I'll get the drawings out within 2 weeks and have fun.